Okay, the last problem we will work in section 813 is example 8-9. And now we'll look at a delta connection, and we want to focus more on the current relationship where the line current is described as the square root of 3 times the branch current. So as we look at this problem, it is, we're just going to follow the same procedure that we did with the other problems that were in Y configuration. We just kind of have to remember this relationship here that tells us about the current relationship. So what that's saying is, if we look at this particular example, that this 22 amps is considered the line current, and it is equal to the square root of 3 times any branch current. Branch current would be, that would be a branch current there. Okay? So, that's what we're thinking about as we go through with this. And then the other thing, let me point out to you that when we're talking about line voltage, it's 550 volts from here to here, here to here, and from here to here. Kind of got to think about this in terms of 3 dimensions, right? So that's where we're coming from, and that's where we're starting with this particular problem. He says, I have a 3-phase, 550 volt, 60 hertz line connected to 3 identical capacitors in delta. And so I redrew that for us here, so here's our 3 capacitors, and the line current is 22 amps. Calculate the capacitance of each capacitor. Wow, looks like we're a long ways from there. So we got to, first off, I think the best thing to do is determine how much current we have in each branch. Then we'll have a current relationship and a voltage relationship, and we should be able to come up with something from there. Now, let me point out something too, and I want you to see if you can see this. Do you see this right here? Let's say that's right here. And do you see this right here? Okay, let's say that is right here. Can you see where that, if I said this is number 1 and this is number 2, okay? And so again, I'm going to say this is 1 and this is 2. Now, can you see that that capacitor in that configuration would reside there? And can you also see that it is seeing 550 volts across there? All right, so important that we see that. Now, so as we go through here, I know that the line current, let's say I had a meter in here and I measured that current in that line at 22 amps. So I sub L equals square root of 3 times the branch current. Branch current is equal to line current divided by square root of 3. I have 22 amps divided by square root of 3, which is 1.73, and that comes out to be 12.7 amps. Okay, so that tells me I have 12.7 amps in each one of these. Now, they're not going in the same direction, are they? One's going in, one's going out, but anyway, so 12.7 amps in each of the branches. Now, let's see, should I draw all? Well, just so you know, that's in each of the branches. So I have basically Ohm's law, right? It says R is equal to voltage divided by current. I'm not dealing with R, I'm dealing with capacitive reactance. So, not a Z, but an X. Capacitive reactance is equal to the voltage across that capacitor, which is 550 volts, divided by the current through that particular capacitor, which is 12.7 amps. And so the capacitive reactance is 43.3 ohms. Okay, now I have a formula that goes back. I can get rid of this now. That says, X of C is equal to 1 over 2 pi F times C. I'm trying to find out the capacitance. So I know that X of C is 43.3. 1 over 2. I know what that is. My frequency is 60. I was given that to begin with. And so what I don't know is C. Now, I guess the way I look at this, I say, well, let's see, I want everything in the denominator in the numerator here. So that would give me, what would that give me? That would give me a value of multiply both sides by C, get this to that point. So C is going to be equal to the numbers. I'll put numbers in here so make sure that you know what you're doing. So I just kind of rewrote this for you. Now, guys, I'm going to point out something. And I know this is something that you've had a long time ago, but if you haven't done this kind of stuff in a while and you're forgetting some of this basic material, of dividing fractions and stuff like that, this is not the time to, run away from it. Let's confront it. Shoot me an email. I used to be a math teacher. I forget. You forget sometimes. This. Like if I looked at this, let's go right here. If I looked at this and I said 1 over 2 pi 60 divided by 43.1, which is actually 43.1 over 1, to divide, you invert and multiply, right? So that was 1 over 2 pi 60 times 1 over 43.1, to get this final answer. And when you do that calculation, you're going to come up with, rounded to the answer in the text, 61.3 microfarads. So that would be the value of each of these capacitors in this configuration. Okay, very neat problem. Didn't that bring in a little bit of almost everything that we've learned up to this point? And that should complete section 813 for us.